Okay, so just be careful, I am recording. Okay. I'd rather not waste this one. So we're looking at page 376. We're talking about algebraic fractions. But we want to, first off, let's just check that we know how to do normal fractions. Okay. So, let's do 2/3 multiplied by 5/4. 5/4. We all know how to do that?
Do you do like keep changing flip?
Nope.
That's amazing.
So if I was going to do 3/7 divide by 2/3, that's the division one. So we've got two options there. Go on for the first one, Matthew.
Would you cross multiple?
Would you cross multiply for the top one?
For the top.
No, you wouldn't. But
For the bottom, when you change the main set to multiplication, I flip it back to the 3/2.
okay, so what we can do here is say it's 3/7 multiplied by 3/2. I'll give you that. Right. Do you know why you can do that? It'd be nice if we did, but at this stage, maybe we can talk about it another time. Anyone know why you're allowed to do the whole keep, change, flip, why it works? No? Does everyone remember that that's sort of a process that you have to do? Okay. Which is lovely, but we still don't know how to do the multiplication bit, so we're kind of stuck there. Anyway, let's Cancellation. So the answer would be 10/12 would be it. And so this one would be 9/14. So we just multiply the top numbers, multiply the bottom. So we actually have 2 times 5 divided by 3 times 4. That's what we've done. Okay. What about simplifying though? Can we simplify that before or after? No?
One with the top.
Either.
You simplify the top one.
We can simplify this one. Okay, so we can simplify that. How do we simplify it then? So,
Divide by common factor.
okay, so 10 divided by 12. So we simplify and we divide by a common factor. That common factor is 2. So we divide by 2, divide by 2, and we get
5/6.
5/6. 5 divided by 6. Okay. Is there any way we could have done that before finding the answer? No ideas? Well, let me take you back to the question then. Okay, so we've got 2/3 times 5/4. What I need you to look at is this bit here, look. What I said was equivalent, so I'm going to just rewrite this. So the answer would be 2 times 5 divided by 3 times 4, and that's the 10 divided by 12, yeah? Okay. What do we know about multiplication in general? Not always. The most basic thing of multiplication that you were told that 2 times 3 is the same as 3 times 2. You can do multiplication the other way around. Okay? So would we be okay if I were to write this as 5 times 2 divided by 3 times 4. So I've changed this top end round. That still give me the same answer? I've still got an equivalent thing. So are you then okay if I split this back up and say, well, that answer is the same thing as doing 5/3 times 2/4? Yeah? Now this is an argument I'm making. We need to see this point, because if algebra is just numbers that haven't been given you yet, and you've got to be able to do everything with numbers that you can, and then when we start working with algebra, you're just applying the same rules. So we need to know what those rules are. So for instance, one where I can actually, all I want is what 2/3 times 5/4 is equal to. What's its value? If I can find an alternative way of getting the same value, then that's fine. I don't need to do a specific question. I just need to get the value of that. If I can do it through an alternative process, fine. So I've decided that 2/3 times 5/4, well, that will give me an answer, and we know it's 10/12. But 5/3 times 2/4 is also 10/12. Okay, so we know it's going to give me the answer. We've gone through the justification. So I've changed the numerator. Well, actually, I've not changed it, but I've changed the order in which we do the multiplication. I've split it back up again. Now, this is a very important thing to be able to do, is to be able to separate fractions back out. The reason why I want to do that is why? What do we notice at this stage now? Bradley?
You can divide the fraction on the right by 2.
Okay, so now I can actually do that one, divide by 2, divide by 2. So now the question is actually 5/3 times 1/2, and the answer is 5/6, which you'll notice is the same as that one. Okay, so that's the difference between simplifying the question before you do it, or simplifying the answer after you've got it. And sometimes, well, quite often in fact, simplifying the question is easier. Why?
So it makes answering easier.
How? You're right, how?
Less steps.
Maybe less steps. I was thinking the numbers are lower. You know, if I've got to do a multiplication and I've got to do 5 times, I know this isn't difficult, but 5 times 1 or 5 times 2, you know, maybe if the numbers are reduced significantly, you know, maybe I no longer have to do 64 times 22. You know, maybe I have to do 3 times 1 instead. So we can actually make the question easier to do. All right. Now, just to bring you back, I'm just going to remind you of something that Matthew said. Do you remember the process of cross-cancellation? So, for instance, I've gone through the process of rearranging it to show you what you can do. But actually, what people will quite often remember is, oh, if I can cancel cross-cancellation, so that becomes a 1 and a 2, it doesn't have to be in the same fraction. You can cancel anything on the top with anything on the bottom when we've got a multiplication. So that would be just a quick way. So now I would do 1 times 5 is 5, and 3 times 2 is 6. Again, I get the same answer. So that would be an example. I'm sure you've seen it, of cross-cancellation. Yes, yes.
Does this work with any fraction? There are 2 pairs of fractions you're multiplying?
Yep.
I'm sorry.
Hang on, let me just record. So, just to, as Jesse said, does that work with any fractions? Well, let's just have a quick look. What if I give you a more complicated question like 5/8 times 3/6 times 2/10 times 4/9. Okay? And I want to do that calculation. Now here's an example where I could do it all in one go, it's fine. But if we can cross cancel, if we can cancel things out, so we're basically using this thing that I can actually rewrite the order in the multiplication any way I like. So all the numerators can be put in any order above any of the denominators. So what cancellation can be done? So actually, my 3/6 could be immediately cancelled to 1/2. Okay. My 2/10 could be cancelled to 1/5. Okay. Anything else? Well, this fraction no. This fraction no. However, I could cancel the 4 and the 8 to 2 and 1. Okay. Is there anything else? So we're looking for, actually look, now this 5 can cancel with that 5. So hopefully you're keeping up with me at this stage. I'm just rattling through it. Now there isn't going to be any more because I've got 1, 1, 1, 1. So I know the answer is going to be 1 divided by, and then I just need to do the bottoms. 2 times 2 is, times 9 is, so 1/36 is my answer. Okay. And that is because I am cancelling out, as you've said, common factors. Do you need a pause moment, or we're out to move on?
Move on.
Okay, so that's multiplication. Let's just have a quick recap then of addition. So keeping it simple, 2/5 plus 1/5 equals 3/5. Okay. I'm going to rewrite that though as 2 plus 1 over 5. 2 plus 1/5. Are you happy with that? Okay. So that's just an alternative way of writing it before we do the addition, and the focus there is, well, we need the common denominator, yeah? The 5 and the 5, the common denominator. So what about if I said 3/7 plus 2/5? Okay?
Okay, so you would find a common factor, a common multiple of 7 by.
Okay, so you need to find the lowest common multiple of 7 and 5, which is 35. So I'm going to change this into 35, okay? And on the top, so this one gets multiplied by, therefore this multiplied by, so we get 15. This has to be multiplied by, therefore this 7, 14. So my answer is 29 divided by 35. Okay. All right, so I just want to write it slightly differently again for you, just so it helps us understanding. So what we're doing is we're breaking it into things that we're doing, which you say is not necessary at this stage when we've got numbers, but when we've got algebra, we need to be able to do it. So this here, I'm going to rewrite as 3 times 5 plus 2 times 7, all divided by 7 times 5. Okay, just to show how it's been done. All right. Not that you would need to do that, but that is basically just explaining to someone what I've done. That's how the fraction has ended up. Okay. All right. So let's move on. If you're happy, you're all happy about adding, subtracting, multiplying, dividing fractions now. Okay. It's all a recap, right? So let's just have a look at a few examples using algebra. So if we want to write them in their simplest form, so I've got basics in the book, 10a cubed divided by 2a. So I've just got a basic fraction and I want to simplify it. Any ideas? Okay?
Divide by 2. I mean, well, that's obvious. So it would be 5a squared.
So the answer would be 5a squared. Is there anyone that doesn't know why? Well, just to explain, if everyone is okay with it, I'll still explain anyway. So I am going to try and find my common factors, and factors are when you multiply things together. So the denominator is 2 times a, and the top, the numerator, is 2 times 5 times a squared. Now I've split it like that, and I haven't split up the final because I want to cancel common factors. All right, so I know now that the 2 here with the 2 cancels out. I'm going to ask you what cancelling out actually means in a probably next lesson. And the A cancel out. Okay. What am I left with as a denominator? 1. So we actually have a 1, but we don't need it. Okay? But I'm left with those ones that don't have a common factor. So we've got 5a squared is simplified. One more is to do with you before I let you do a few yourself. So 5x squared plus 3x to the power of 4 divided by 2x to the power of 4. Okay. Bradley.
Yeah, 5 plus 3x squared.
So you think, so don't write this down yet, guys. So you think it's 5 plus 3x squared all over 2. Are you changing your mind?
Yeah, in my mind. 5 plus 3 x squared
5 plus 3 x squared
over 2x squared.
over 2x squared.
Could you do the x squared and x squared, or since the
Well,
other one-
so this is the big question. This is where people struggle. Yeah, we've got to think, what would I be able to do if I was working with just numbers? Okay.
Right.
So what I'm going to do, this might seem like a long approach, but I'm going to do it like this. So just don't write at the moment, just follow through what I'm going to do and then we'll write it down afterwards. So, it's an add, yeah? Do you remember up here, I split it like this when I'm adding? Now I'm going to go from this back this way, but with my algebraic one. So I'm going to rewrite it. If I think about this, I'm going to rewrite it as 5x squared divided by 2x to the power of 4 plus 3x to the power of 4 divided by 2x to the power of 4. So don't write that yet, but does that make sense? You're happy to do that, okay? All right, could we simplify those fractions before adding them together? Now. Okay, so Bradley, have another go. What would this one simplify to?
5 over 2x squared.
5 divided by 2x squared. Yeah? So this would be 3 over 2. Okay. Now this is why I said don't write this down, because I now have a problem that I've created for myself, which is what? So yes, I can't add them back together because my denominators are the same. Does that make sense? So what do I actually need to do to the right-hand side? I don't want to simplify it fully. I need to take an x over. Is that what we do when we're adding fractions with numbers? Do we take numbers from one side to the other? What do we need? How do we add fractions together? We need to find a common denominator. So what would the common denominator be? 2x squared, because this one has to be 2x squared. So that would make this. Now, what we can then do is we can put it back together and write it as 5 plus 3x squared all divided by 2x squared, okay? Now this is why I said don't write and just listen at this stage, is because if I compare that answer to where I started with, we should be able to look at, we've done everything I'm allowed to do. I'm hoping that in the future you won't need to do that whole process, it's just for understanding. But what can I do then? What are the rules that I can apply to go straight from the blue to the final red? What do I need to make sure happens? Any ideas? I think Bradley was partly there, not quite. And a couple of common misconceptions there. No one spotting it? I think the bit that you did spot, Bradley, was if you cancel with this denominator, you have to cancel with both terms. All right, and what I've seen by splitting it up, they have to be cancelled in the same way. Why? So the denominators stay the same. All right, so I can't pick that x to the power of 4 and just cross this one out, because that wouldn't be doing this one here. I'd be ignoring this side. So what I need to do is I need to find the highest common factor of both sides of the numerator that works with the denominator. So what is the highest common factor? The x squared. So I can cancel the x squared because this then becomes x squared. But if I cancel an x squared here, it becomes x squared still. Okay? And that's the highest I can actually do. That's the largest factor I can do, as seen by breaking it up in this way. So you see how I can do that? I've got to do it in both parts. In fact, if I've got a third part to the numerator, it's got to apply to all three. What were you going to say there, Frankie? Okay. Eyes closed again. You keep mentioning it. So, does that make sense? So write that down now. Now you can. And then have a look. We've only got 5 minutes, but if you turn to page 377, we're looking at practice 2. We did question 1 and 2. Have a go at some of the other ones. See what you can do. See whether you can apply the other knowledge that hopefully you've got to this stage.